Hi, my name is Caitlin.
I'm Grant.
I'm Mo.
I'm Mason.
I'm Riley.
I'm Pranav.
I'm Jaron.
I'm Sean.
I'm Kathy.
I'm Sammy, and we are the Prosper Solar Car team. We are from Prosper, Texas. We've been part of the Solar Car Challenge since 2015. This year, we've organized a team by components of the car. Each member here will talk about the different components and the decisions we've made. This year, we've tried to really focus on our aerodynamics and the rolling resistance, as well as the weight of the car, which we stand around 700 pounds.
My job was to improve and streamline the design of our car while aiding in the CAD and design process. Our CAD team was in charge of providing designs and documentation to the welding and manufacturing team, all of which was done to a high standard and to an overall tolerance of 1/8 of an inch. We focused on weight reduction and structural integrity, and through trusses and a change of materials, we cut the weight of the old frame in half while maintaining the strength.
Some of the materials we used to achieve this are the following: chromoly, which is our main frame, it's 3/4 of an inch, and the chromoly also has a round variant instead of square tube that we use for the roll bar. We also, you can't see in this picture, but there is a crush zone out of 1/2-inch chromoly. Then for the array support for the solar panels, we used aluminum because it's lighter weight and we don't want the car to be too top heavy, otherwise it will roll over. Then we have the PVC pipes that we sort of bent around, not PVC pipes, PVC sheets that we bent around the wheel well to add structural support. Later on, we added a fully 3D printed part of PLA, just a little inlet, so the air doesn't get stuck in the wheel well causing a bunch of turbulence, just a little pass-through to get it out. Then we also have the steel wire, that is the skeleton of the aerodynamic shell that we put white shrink wrap over to make it aerodynamic. Over here we have the canopy being made. This is flat steel wire, which we later put on a clear Lexington polycarbonate sheet for the windshield. Over here is one of our prototype parts of 3D printing the kingpin. We didn't use this as final design, just didn't fit with the wheel assembly over here. So we just changed it, and we 3D print prototypes just so it's not as expensive and wasting a bunch of aluminum in case it doesn't fit.
Here you can see the body of our car. We started building it as soon as the rolling chassis was complete. The goal was to cover the pre-existing frame with a shape that combined small frontal surface area with reduced turbulent air leaving the car. The body is built out of 1/16 inch steel wire, which is wrapped in a layer of shrink wrap. And next we have a sliding canopy that we attach for quick and easy entry from both sides of the car. It's made out of clear polycarbonate sheets riveted onto a thin steel frame. Last is our solar array. It consists of 8 22-inch by 68-inch panels held together by a 60-61 aluminum frame. And all that's held up by 6 support bars made out of 3/4 of an inch chromoly steel.
For the interior panels, we use PVC as it was durable and easy to shape. We placed a 12-volt battery and cup holder on the side panels so that everything the driver needs is accessible and within reach, but not in the way of the driver. For the console, we started off by making a CAD design and then used an aluminum sheet metal base for the surface and then 3D printed the sides to hold it in place. We also made it so that the 12-volt accessories and buttons were within reach of the driver, but not in the way of the driver's vision.
For the drivetrain, we tried to focus on weight reduction and low rolling resistance. For this, we used junior dragster wheels, which have a really small contact patch, as well as ceramic tapered bearings, which perform under high load and perform really well under high load, and they have a really small, and they have a really good, they're really smooth. And so with that combination, we CNC'd our own parts out of 6061 aluminum, and we used, this allowed us to customize and make weight reduction as well as have the perfect fitment for our wheels.
We used a racking pinion steering system because this is the simplest type of steering system we could use, and it's also the least likely to break. One of the crucial parts of the steering system was the Ackerman geometry, and we used this to ensure the wheels would rotate properly and the car would turn the way we needed it to turn. And we just used the brakes that we currently have on the car because those brakes are very powerful, so they can quickly and safely stop the car, and they're very lightweight.
We chose to use a lithium iron phosphate battery rather than lead acid, as it has a very good energy density. And with that lithium battery, we chose to buy it pre-assembled rather than attempting to assemble it ourselves, because a pre-built battery is going to be much more reliable than one that we are trying to build ourselves. The motor controller that we chose that one as it's compatible with our motor, and it's also very easily programmable.
The solar panels on the car are 900 watt and are able to provide a reliable source of power for recharging the battery pack. These are crystal panels that are not too heavy, but efficient enough to be a capable power source. In addition, we needed to be able to track and adjust the power coming into the system, which is what we can do with the MPPT. It's a power tracker that allows us to read and understand how much we're taking in and can regulate the current moving from the panels to the battery. Here in this diagram, you can see the overall final electrical system.
The telemetry is made of two current sensors that relay the amount of amps coming from the solar panels and the batteries. This information is relayed to the Arduino, which is connected to a transmitter receiver, allowing us to see the information and make changes accordingly. This helps us a lot with the strategies. The topography map also helps us see that anticipates hills and allows us to tow the car up said hills and allow us to gain more miles near the end of the race.
Last year, our team was not able to compete because of our team organizational structure. In fact, we had to build a car from scratch. This year, however, we were able to structure our team effectively, gain valuable knowledge through research, and problem solve each step of the way, which spurred our efforts to build a vehicle to compete. As a team, we are proud to present our solar car and are ready to drive. Thank you.